Hello, everyone. My name is Tatiana, or Tanya, and I'm an Android engineer at Life360. Life360 is a #1 family locator app and safety membership. Protect and connect your loved ones, pets, and important stuff. Experience our advanced driving, location, and digital safety features. You can also connect your tiles and see their locations on the map. So the major key points on today's talk are how to create multi-process Android applications, pros and cons, understanding of the process lifecycle, ways to implement inter-process communication, and how Life360 created publish-subscribe system that is multi-process friendly. And why this topic? So we have the multi-process architecture in Life360 for a while. And we basically have our main default process where our main activity lives, and it communicates with a cloud. We also have a service that lives in a different process that also communicates with a cloud. And sometimes two processes talk to each other. And every time I talk about some of the nuances, I get a question from my coworkers. Why do we still using it? Aren't new devices have enough memory? Like, why not just to use a single process? So this talk aims to address those questions, and hopefully for all of you, you'll be able to understand whether you need multiple processes in your application. So to start with, how does a multi-process work on Android? Each process runs in its own instance of Android runtime and have a unique process ID. Processes also isolated from each other and have a separate memory space. However, just because you have code running in a separate process doesn't actually mean it's running on a separate CPU. So don't get confused. We have no control over that. Android system handles it for us. And how do we introduce another process? It's actually fairly easy. It's much easier than understanding all of the implications after. You just add the attribute, process attribute, to either your activity, service, receiver, provider, or even application. So you add the process name, and the final process path would be your package name plus the process name. Let's go over pros and cons. Let's start with pros. Per process memory limit. I'm sure many of you know that we have a hard limit on a heap size, and it's based per process. Yes, we don't experience out-of-memory errors as often as we did back in the day when devices had very little memory, but we still see those errors. And if you're curious to check on your device how much memory is dedicated to each process, you can call Get Memory class in Activity Manager. And as an example, actually any application where you have extensive memory usage in one process would benefit doing something in another process. Another one is each process has its own life cycle. That means we can remain alive even if the main process is terminated. We have no control over the process lifetime. Application doesn't have control. So Android system can kill it at any moment. An example of the app that would benefit from this is the music streaming app. Imagine you have user close your app, but you still have a service that's playing the music in the background, and it's not interrupted. And it's important to know, since Android can kill our process at any moment, that there's a hierarchy of processes, and most important ones are foreground processes. These are our activities, resumed activities, and broadcast receivers that are currently working, service on create, on start, on destroy. Next in priority are visible processes. These are paused activities and also services started as a foreground service. Then we have services and cache processes. So if you have a service, you need to know that if you start it as a foreground service, you're actually going to increase the importance of that process. And it's going to be less likely to be killed, or it's just going to take more time for system to kill it. Security. Since we mentioned that we have a separate memory for each process, obviously that means that data is secured, and it's actually helping us to provide access, secured access to that data from either other process or even other applications. An example for that could be a banking application where you can handle financial transactions on a separate process to make it more secure. And the last one is enhanced stability. Imagine you have hundreds of engineers that work on new features every single day, and you have your backbone technology working on a separate process that will never be interrupted by any crashes or issues on the main application process. So that's definitely a big one, big benefit. Let's go to the cons. The first one we're going to talk about is increased memory usage. It's funny that I mentioned that we do use separate memory space for each process, but that means memory overhead. Two processes together combined is going to take more space than a single process with that functionality. And if you have devices with very little memory or running out of memory, you will experience slower performance, battery consumption, increased battery consumption, and device slowdowns. So the example of application where it could be possible, for example, e-commerce app, where you just want to move product listing and shopping cart into different processes. It just makes no sense to do that. There's no reason to do that. You're just going to duplicate the data and you gain no benefit from it. And another one is a big one, communication overhead. IPC, inter-process communication, it's going to introduce latency. If you need two processes to communicate, you probably want to avoid it in the first place if you had that opportunity. And we actually, up until recently, didn't have any IPC in our app. And that's why we were able to not have this complexity. And example is a messaging app, right? When you have a sender and the receiver on different processes, this is just going to create latency if you compare it with both being in the same process. And maybe that's latency is okay, as long as you understand that in this particular case, you're okay with latency, and maybe it's a rare use case, then that might be not an issue for you, like it is for us. Like it's not for us. Another one is complexity and maintenance. We definitely increase development effort and maintenance. Debugging and troubleshooting can become challenging. Example could be, imagine you have an audio and video playback in different processes, just synchronizing them to work smoothly for the user is probably a nightmare. And another one is compatibility issues. Not every feature or library supports multiple processes, and shared preferences is one of them. What we actually have a coworker who created his own library. It's called Harmony, which is basically shared preference for multiprocess environment, and it works for us. So we were able to avoid IPC because we had the little bits of data just synchronized, and we never talked between the processes. So this is how we avoided this issue. And just to summarize, there's a lot of good and bad why in Life360 we still decide that it's absolutely worth it to have multiple processes. First one is that we want to be able to create a lightweight, high-priority foreground service that consistently delivers our sensor data. This is a backbone of our technology, and it's crucial for us. And of course, the security of the data, we have no interruptions from crashes and issues. We have very limited IPC implemented. And as I mentioned, we were able to avoid IPC at all prior. And another point, relation to debugging, we developed our debugging tools. We have multiple login mechanisms. And basically, we can request logs remotely from any user from multiple processes. And that just works. And I don't know if you ever noticed that on Android Studio, you can actually debug and get logs for separate processes. So you don't have to, you won't be confused to get logs from both. You can just separate them. And another one is we definitely acquired an expertise over the years, and we are confident we are going to support these features, all of the features that we need. Okay, since the biggest overhead is the inter-process communication, I think we should just go over some of the most common ways to implement it. And one of the simplest is, I'm sure all of you used before, it's sending intents to either pass some small message or start an activity or a service. So, and definitely it's good for one-way communication, it's good for small messages. And it's not good in cases when you need real-time, long communication. You need the channel to be opened for back and forth communication. So you don't want to use it for that type of IPC. And one of the examples where you could use it, imagine you receive push notification in your main app, and what happens, you create an intent and you start a foreground service with that intent that contains some certain information or action that your service from another process can start doing, right, based on the received push notification. And here's just a brief example of how to send the broadcast and how to create a broadcast receiver and register it. And in onReceive, you will just get the event. Another one is a content provider. It's also very common. It's a standard interface to access and change data in another process or another application. So what it's good for? It's good for modifying and reading structured data across different processes, and it also provides a secure way to do it. What it's not good for is when you don't need it, communication between processes, so you don't want to create this overhead, even though you can create content provider and use it just within your own process. And the example could be, let's say you store logs in one process and you just want to access them and maybe send them to the cloud in another, or do something with them in another. And that could be a good way to just access the data. And this is just a brief example of how would you create the content provider. You would implement methods like query, insert, update, and on another process, you would just get access with your URI. I'm sure many is familiar. This is a standard for Android. And yeah, you just query using the content resolver, and you can get the data from another process or application that way. Another one is bound service. This is a client-server communication model where what it's good for is long-lasting communication. It can go back and forth. It's a two-way communication. And what it's not good for is, well, when you actually don't need to maintain long-standing communication. And as an example, imagine you have a music player and you have another process where you have play button and pause button, and you just want to keep that consistent communication to react quickly on, let's say you click pause, and you want to immediately cause an action on another process where your audio is actually playing. So you just want them to have them bind, right? This is called bound service because we bound two processes together or two applications for some long period of time. And again, this is just a brief example. You simply create a new service and you create a binder object inside, and that binder object is the way for you to access from process B to the service in process A. So you would call bind service inside process B, and inside the you create the connection, and inside the on service connected, you can access your service and everything that's inside. And another one is the messenger. And based on the name, you can probably guess that it's good for message-based communication, just for really simple messages. It has all the messages are building up into the queue. So if you need to handle only one message at a time, this is actually a good, simple way to do it. However, if you need high performance, right, you want multiple messages going in at the same time, this is not going to be the best choice. And example here is just a text messaging app, right? If you don't have a lot of messages at the same time, that might work for you to have them in separate processes. And here's a simple example. We just create the messenger with the handler and send the message from process A. And in the process B, we create the handler and receive that message. And the last one, the least one used, Android Interface Definition Language. So most of you probably would never need to do it. It's a way to define programming interface for both client and service. So what it's good for is when you need just a high level of flexibility and control over the communication and handle different scenarios. It's a two-way communication when you need to handle callbacks, and especially when you need to create multiple requests simultaneously. Like Messenger cannot do that. Android Interface Definition Language can. And, excuse me, an example is application where you can request, let's say you have a GPS service that tracks user location and in one process, and you want to call another process and say, hey, this is my location, can you give me all the restaurants nearby? And then you would wait for the response from another process that accesses the storage with all the restaurants in that location. So this is one of the examples. And similar to other methods, you just create a connection in process B where you're able to access your interface, but unlike binder and messenger, you're going to have your custom interface. So that's the biggest difference. And in your process A, you're going to create custom interface and implement it. And there's a lot of what can go into the IPC, and there's so many nuances. It's probably a topic for a whole talk on itself. So I'm just going to move to Life360 event streaming system and how exactly we implement IPC in it. So what is event streaming in general? It's a practice to capture data from all kinds of sources, like sensors and database, storing this data, maintaining, processing, and routing it to different destinations. We created publish, subscribe event system based on Kafka. If you're interested to know what this is, check out the Apache Kafka. We don't use Kafka itself. It's a cloud-based architecture. It's actually a tool, a library. We just looked it up, and it felt like we would want to have something similar on mobile because it's very scalable, fault-tolerant, it has a very high throughput. Basically, you have real-time events flowing and persisted. We have producers and consumers completely decoupled, which enables the scalability because consumers and producers they don't care about each other. They don't know anything. And because we have events persisted, it gives us traceability, predictability, and those events actually immutable, which gives us a slice and history of everything that happened in our application. And one more thing, it's good for testability, since we can mock any kinds of data. We create events, and we can just create those test cases, replicate those test cases. So our system has 4 main components. Events, it's just facts that something happened. For example, we have a location, right? It has a latitude, longitude, and timestamp. Then these locations are organized into topics. Topic is just a type of data we persist, similar to a storage type. And we would have, for example, location topic. It holds some of the properties that all the location events would inherit, like what is the prune policy, how often we want to prune the data, etc. And of course, we have the producers and consumers that publishing and subscribing to our events. And I'm sure everybody is familiar with this flow. The producer publishes, but here we have our topic, and consumers are subscribing and receiving the messages. So what we did, we created our custom library that's called Events Kit. It contains those 4 components. Underneath, for persistence, we use SQLite. For IPC, we use Intents and Content Provider. And to avoid data synchronization, we decided that each topic type will be persisted only on a single process. So imagine if you have a log topic, right, where you get all the logs of everything happening in your app in the last 3 weeks. There could be hundreds of thousands of messages, and we actually don't want to duplicate that data on 2 processes. We want it to be stored on 1 process, and if another process wants it, well, you have to get it through IPC. And here's the example flow, the publisher flow. Imagine we have only single process, so that's easy. We have a publisher for topic X, and we want to publish to Events Kit. Events Kit then asks the multiprocess resolver, is this process on this topic? And multiprocess resolver says yes. Okay, it's perfect. We just save this event into storage, and we emit it to subscribers. Now, imagine if we have topic X belonging to process B, so it's stored in process B. And then publisher from process A wants to publish into it. How it works, it also tries to publish into Events Kit, and Events Kit has its own instance of multiprocess resolver. It's asking, is this process on this topic? And the answer is no. And what it does, it basically sends a broadcast, as we just discussed the intent-based communication for IPC. It sends a broadcast, and the receiver on another process gets it and publish it into the events kit, its own instance of events kit. So we have two instances of events kit, and in the process B, it's all easy because now we know the process B owns this topic X. So we just save the event and emit it to subscribers. How about the subscriber flow? Again, a single process case. Subscriber wants to get events from that topic X, right? Maybe it's location topic. Then it asks events kit. Events kit again asks the MP resolver, and yes, this topic belongs to process A, so it's easy. We just get it from the storage, and we get it back to the subscriber. And the case with two processes, now imagine that topic X belongs to process B. Here we have the subscriber X in process A who wants to get the topic events. And it requests the events kit in its own process, and then a P resolver says, no, we don't own this topic, so here's the content URI for the content resolver, and we call content resolver query, so basically we use the content provider, and it's another method that I talked about, and it just accesses the storage from another process and delivers the event to process A. So those are two different ways, two different IPC that we use, and as you can see, it's fairly simple, and we try to build our topics in a way where this almost never happens. So for the majority of use cases, the subscriber and publisher will live in the same process. But if we do need it, it can be done. So what are the alternatives to the way we implemented it? There's something new coming out, which is, it's already came out, Preference Data Store. And starting with version, I believe it's in alpha now, 1.1, it's going to support multiprocess environment, which is great. So it could be a good alternative for our library that's called Harmony that our coworker created. Another one is using Room database. However, there's a caveat. So we didn't use it initially because we were still in the process of migrating other parts of the app. And the way Room database supports multiprocess environment is synchronizing data. And for us, we don't want to synchronize data. We don't want to duplicate data on both processes. So it's actually not critical for us to have it. So if we would just replace SQLite with Room database, we would still have to use our IPC mechanism. And here is the summary. We just talked about how to create multiprocess applications, pros and cons, the process lifecycle, and ways to implement IPC. And we also talked about the events kit, which is the event streaming system to deliver events in a multiprocess environment. And we are not outsourcing it at the moment, open sourcing it at the moment, but we will in the future. And that's it. Thank you.